The next topic I'd like to cover is position data. Now, each position here has position data. If you go to the position number right there, you can press position right here and see its position data. This shows the X, Y, and Z value and the yaw, pitch, and roll of this position. So this information is very helpful, and it does allow you to modify it in this way. For instance, we're looking at position 3 right here, and if we wanted the Y position to be over 100 millimeters about, we could say 1, 2, 2, 1. And now it has a new position. You notice that moved right there. So we could move that even more if we wanted to by saying 2000. And this position moves. So you're able to adjust positions very easy through this method. You can do this through the background editing if you need to, but keep in mind this is not something you want to take too lightly. If you modify this position incorrectly, you could cause a crash. And one thing to note is this configuration data right up here. This configuration data has certain values right here, which are shown in the manual to have these definitions. Go ahead and pause the video and review these as needed. The big thing to pay attention to is if you are moving the robot around, and if you modify these values right here, you have to pay particular attention to any orientation of the robot. If it passes any like 180 or 90 degree marks, such as if I had to adjust this position from here to here, I would be very concerned about doing that because I would be passing this 90 degree mark right here where the robot would rotate on its first axis. I wouldn't be too sure if the configuration would be the same for that point right there. Now, because it's on the computer, it's a little easier to tell this, but when you're actually working on the site, it's a little difficult. So the big thing just to pay attention to is this configuration data. I can't quite give you a good example of when it will fault out, for it's a little difficult for it to fault out, but when you get the axes near their 180 degree marks or their 0 degree marks for their yaw, pitch, and roll, it could cause a few issues because of this configuration data. To keep it simple, you do not want to make any major changes in the XYZ here without first checking the position. Some minor changes should be okay, but it's just going to take some getting used to for you. You can make these changes while you're in auto, either by going to a background edit, changing this position data, or if you're changing some position register data while it's being used. For instance, if we record this position here, we can go to its position data and change it there. So we could say 2500. You can do these changes here, but I highly recommend that before you make any permanent change here, you have a good idea of where that position is, what this change is going to do, which direction the XYZ is, and only make minor changes at a time if you have to do this in auto. It is still preferable that you always check your position after making a change. Do not make any changes to the yaw, pitch, and roll while you're in auto, that could be disastrous, for those are far more likely to mess with the configuration settings. The XYZ position values can actually mess with the configuration, and thus you could have a major issue where the robot's just not going to go to the position you thought it would, but it's far less likely than if you mess with the yaw, pitch, and roll. Another thing you can do while you're in this position data is you can change the representation from Cartesian to joint and back. It is important to note, however, that whatever representation you keep it in, it will keep in that data. So right here, this is now in joint representation. This could mess with some math that we use. For instance, if we make a backup of this file, so we're just going to make a new directory and call it test, backup the ASCII programs. If I pull up this file right here and we go to the Training 3 program, when I pull this up, it is now going to show that position 3 is in joint representation. These other positions are in XYZ. Before I show you an example, I want to modify this position data back to Cartesian. So now it's back in Cartesian. Now what I'm going to do is I'm going to modify this position data in the program. So it's not a manual modification, it's through the program. Oops. What I want to do is I want to set position register 3 equal to position 3. And then I'm going to change position register 3 position value 2 to a certain value. So I'm going to set this to 0. When I move to this position right here, I'm going to first change this to a position register 3. It'll move to this modified position. So I'm going to shift, press forward, and it's going to move from there to the modified position right there. So this is the same point as position 3, but with its y value at 0. Now this value right here is the position data value that you are modifying. 1 is x, 2 is y, 3 is z, and then it's 4, 5, and 6 is yaw, pitch, and roll. If, however, you have the representation in joint, then 1 there would be joint 1, this 2 would be joint 2, 3 would be joint 3, and 4, 5, and 6 are joint 4, 5, and 6. So that's what you need to pay attention to. If you change this representation, it may mess up your calculations for any logic that you have in your program. So this is something very important to keep in mind. The other thing I want you to be aware of is when you are blindly adjusting these position values, you might accidentally move the robot out of its limits, or you might cause some configuration issue depending on exactly how you move it. The configuration issues are not too common, but they can occur when you're moving the robot near a 90-degree section. For instance, if we're near a 90-degree section of the first joint right here, notice it's right there. If we move this way or that way, then the configuration data might change. For instance, if you moved a little clockwise, then the robot might think its configuration data is one set. But if you jogged it the other way, the configuration data might be a little different. Thus, when you just blindly adjust the values, you could run into an issue where the configuration data is not what it should be, and thus the robot might think it has to rotate the axis in a different manner, and that might mess up your motion.